Hello, Wayland Middle School. Mr. Farley here for another exciting award-winning video. This time we're going to be talking about graphing nonlinear inequalities. Again, this is pretty good stuff. You'll probably recognize the inequalities that are listed on this video because these are the ones that Mr. Robinette did before, but they were equations. This time we just switched it. I switched these into some inequalities. Just to see what happens. It looks a little bit different, but it should be pretty good. It follows very closely what we did with our the last video as well in the last lesson. Anyways, let's get going here. So I'm pretty sure everyone's seeing absolute value. You should be thinking a V. You should see a negative outside. That tells you an upside down. And you see a +4, you know it's shifting up 4. And you see a -2 inside, which means it's shifting to the right 2. So the vertex here is going to be at 2, 4. This is the vertex right here of our V. And we do know that it looks like this. All right, which is fantastic, making a beautiful V right here. And I will extend it. There we go. That looks pretty good. So this is your absolute value. This is what the graph looks like. If this was an equation, remember, we would connect all of these points, put arrows on it, we'd have solid lines, and we would be done. But with inequalities, it's a bit different. What you need to do is consider the inequality symbol again. This time we have a less than. I'm pretty sure we remember from the last video that if it's a less than or greater than, what we're going to have is a dashed line, okay, connecting. So I'm going to put a dashed line connecting these. And that's not super easy with this pen I'm using here, but that looks pretty good. Dash line, ta-da, put arrows on it. That's really great. So that's what it looks like. But now remember, we're looking for the solutions that satisfy this inequality statement. Just like the last video, I'm going to pick the origin. Origin's nice and easy to work with. Let's see if it works right here. So I plug in the origin. Origin is 0, 0. When I plug that into this inequality, I get y is 0 is less than the opposite of x is 0 -2 +4. I just plugged in 0 and 0 for my x and y coordinates. Now when I clean this up, I get 0 -2 is -2. I take the absolute value of that, which is 2. This makes it a -2. And when I add 4, I get a +2. I get this statement when I write it right up here. 0 is less than +2. I'm pretty sure we agree 0 is less than +2. That means the origin is one of the many solutions to this inequality. All right. It also means that all of the points in the same region as the origin will also be solutions. So I will need to shade in with my pencil lightly all the points that are located in that region. So I'm going to try to scribble this for you, but you get the idea. All the points in this region will be solutions to that inequality. All right. So there you have it. That's the solution to that. And you can show it by the graph. You need dashed lines because the inequality symbol is just a less than. And you need shaded in regions because the origin in this case satisfied the inequality. All right, so that's the first one. Second one, let's take a look at this very quickly. And you'll recognize this one again. This was used on a previous video. So we have x + 2 squared. Hopefully you're thinking this is a u. I'm realizing the origin is at -2, 0. If I make my table of values, I'm trying to do this quickly here, so the video is not too long, but we would get these points right here on our table of values, identify this inequality statement. It has an or equal to, therefore this would be a connected curve, not dash like the first example. There you have it. And now let's test and see what happens. Again, I am going to test the origin. Origin's nice and easy. Test that point, 0, 0. Does it satisfy this inequality statement? I don't know. Let's see. Y is 0. Is 0 greater than or equal to 0 plus 2 squared? And if we do that, I get the statement 0 is greater than 2 squared. Uh-oh. Is 0 greater than or equal to 4? Well, no, it is not. That means the origin is not part of the many, many solutions to this inequality statement. So because of that, I know that the region that needs to be shaded in will not contain the origin, or it does not contain the origin. That means it has to be this region in here. So all of the points in this shaded region are solutions to the inequality statement. That's what we're looking for. This is your solution. This is what the graph looks like. And you can see that there are infinitely many points in this shaded region, okay? All of those points in here satisfy this inequality statement. So it's not that different than the last video, but now we're just dealing with the nonlinear inequalities. Keep in mind, absolute value gives us v's, quadratics give us u's, and that's pretty good. As usual, if you have any questions, let Mr. Robinette and I know. We'll get back to you really quickly. Hopefully you enjoyed this award-winning video. Take care.